Okay, this is example 1 in your book on page 278. Again, you're more than welcome to read the book. I just wanted to maybe fill in some gaps if it was necessary. So the main, I'm going to be using theorem 1 in your in this section, which is transforms of derivatives, because we're gonna have derivatives, obviously. And we're also going to use the corollary, which is transforms of higher derivatives, specifically higher than 2. Okay, so let's solve this initial value problem, right? We have our initial conditions and we have our differential equation. And I actually forgot one thing. That should be prime there. And okay, so let's go ahead and take the Laplace transform of both sides. So here we have the Laplace transform of x double prime minus x prime minus 6x. And I'm going to take the Laplace transform of the right-hand side, which is just going to be 0, well, of 0. And then again, using the property of linearity, right, the Laplace transform, sometimes we say it's a Laplacian operator of linearity because you can definitely break up the terms. So let's go ahead and do that. So we have the Laplace transform of, right, this guy, and this guy. So x double prime, I can go ahead and write just minus the Laplace transform of x prime, right? And then I'm going to go ahead and just take out that 6, right? We can take out that constant. All right, using again the property of linearity. So we have minus 6 times the Laplace transform of just x. And the Laplace transform of 0 is just 0. Now, recall that x double prime really means x double prime of t, right? X prime of t. This is really x of t. That's the goal. We're looking for that solution. Again, if you want to write in the t, that's fine. So in your book, I'm looking at so theorem 1 has equation 4, and we have the Laplace, well, let me go ahead and write it down and then just kind of explain this. So we have the Laplace transform of f prime of t, right? Okay, that's if, I mean, it's a function of t where we have x, so I'm going to use capital X or chi. Let me just go ahead and write that down though. Equals, okay, so this is really s times, right, the Laplace transform of f of t minus f of 0, right? But we know that the Laplace transform of f of t is really capital F of s, right, from section 4.1. Right, our notation minus f of 0. Okay, so we know that this equals this. Okay, so keep that in mind. Right, that was equation 4. And then I'm going to look at equation 5 and just write that out. And equation 5 is really just finding the second derivative, right, the Laplace transform of the second derivative. And again, we have, it's very similar. The only difference, right, is now we have s squared times capital F of s minus s times f of 0 minus f prime of 0. And you can see where they derived it. You can look above on page 278. It's a very nice explanation. But these are the two formulas that I want to use, right? Because I have this and I have this, right? Here's my double prime, and here is my the first derivative, the single prime. And notice that in the book they use, or in example 1, they use this capital X, right? Again, if you wanted to use capital F, but we'll just use chi of x since our function is really x of t. I mean, F is very general, some function. We can call it h of t and use capital H of s. So let's go ahead and I'm going to go ahead and change this maybe to, okay, so this guy is really, right, that's really little x. This is really big chi of x. That's really little x, right, because our initial conditions are x of 0. And this guy is really big x, or chi, and these guys are little x's. Again, if you want to rewrite those. Okay, so this is 5. And let's go ahead and insert all these guys. Okay, so the Laplace transform of x double prime. Well, it's right here. So that's s squared chi of s minus s times x of 0, right? Little x of 0, minus x prime of 0, right? That's equation 5, not an s. Let's make sure, there we go, we don't make a mistake there. And then we have the Laplace transform of x double prime. So let's see, let's do some color coding here, maybe it'll help. Okay, so this sky is my blue, right? That's this sky, right? Which is this sky. And let's see, let's use maybe green. And then my first derivative, right? Well, it's right here, which is right here, right? Or maybe do that. Okay, so we have minus s, right, times chi of s minus x of 0. Okay, that's my green part. Okay, and then finally we have, again, so just to see where we're at, right, we've got this sky, right, our blue, right, we've got our green, and then it's minus 6 times the Laplace transform of x. Now, the Laplace transform of x, remember, it just denotes, it's the Laplace transform, right, of some unknown function, right, in this case, x of t. So we're just going to, we can denote that by capital X, or chi of s. So let's say, let me maybe move this a little bit over here. So minus 6 times chi of s. Again, it's just, it gets tedious writing the Laplace transform of x, the Laplace transform of x. So we just call it chi of x. So that's this guy right here. And then that's equal to 0. And I'm going to go ahead and stop right here just because it's about 7 minutes, and I'm going to go ahead and continue simplifying this equation to eventually, right, arrive to our solution to our differential equation, right? Remember, the goal is to find, right, x of t. Okay, so I'll stop here again and continue in the next video.